Okay, so one interesting thing about this difference equation. So first I thought that this difference equation will the value of y will be infinity sometime, because all the time you are summing the input with the previous output, right? So I thought that this might be go to infinity, but when I run this simulation I see an interesting thing. Well, so you see this value is converging to some value. Okay, so now I see that this value is converging to 10, but why this is happening actually? So let me examine this thing. So when, let's say when n is equal to infinity, then y infinity, then a, y this infinity minus 1 will also equal to infinity, then x infinity, and then let's find y infinity, which is simply is equal to x infinity 1 minus a, if I rearrange that equation. So if I set x infinity is a DC voltage, let's say un, I mean 1 1 1 1 1, let's say this is actually x. So what I will get, I will get the infinite time, I will get a finite value here, right? Let's say a is something less than 1, let's say a is equal to 0.9, then I will get y infinity is equal to 1. As you see that this value is all the time 1, that means when the time is infinity this x is also 1, so I have put here 1. Then a is 0.9, so you see this is actually 10, and that's why this thing is approaching the value 10. And now let's do this in another way. Let's say this is yn, this is yn, which is equal to, let's say 0.9 yn minus 1, then xn, right? That means now let's do this manually. So x is all the time 1, let's say initially this is actually 0, so yn will be 0 plus 1, which is equal to 1, right? Now at the next time this 1 will appear here, so this is actually 1, and this input is always 1. But wait a minute, now it is multiplied with 0.9, so we will get 0.9, and now if I sum this two thing I will get 1.9. Again this thing will appear here 1.9, but 0.9 multiplied here, and I will get 0.9 plus 1, this is actually 1.5, and I have to do this, and I have to do this thing, and after some time I will get okay, so after a long time I will get output is 9.17. okay, now let's work with this thing. So at the next time this 9.17 will appear here with a 0.9, and the input is again 1, and now if I sum this two thing I will get 9.25. again this 9.25 will appear here with weight of 0.9, which I have to sum by 1, and I will get now 9.32. and then if I do this again and again I will get, oh, I am actually approaching to 10, right? Like this equation. So now let's find now let's see yn is equal to a yn minus 1 plus xn. So those who knows z transform, we know if I transform this thing I will get yz and then a, and if I transform this thing I will get z inverse 1 yz, and this thing will be equal to xz, right? Okay, so we can write yz is equal to 1 plus a z inverse 1. And now what is xz? Let's see what is xz. So we know xn is equal to un. So if I transform this thing, maybe I will get 1 by 1 minus z inverse. Okay, so let's write this thing here, 1 by 1 minus z inverse. And then if I take this thing at the right hand side, I will get 1 minus z inverse 1, then 1 plus a z inverse 1. Okay, so now we have to decompose this to fraction, 1 minus z inverse 1, then here 1 plus a z inverse 1. Oh, you see one mistake, this is actually not plus, this is actually minus, so this is minus, so here I need another minus, and then let's see how to decompose this thing. Okay, so after some calculation I have to do this thing, and now we have to, so this is actually yz, right? So now we have to again convert it into y, and what will be this thing? So this thing will be 1 to the power n un, then minus a to the power n un. Well, so this is my yn actually, and now let's analyze this thing. Let me rearrange this thing first. 1 minus a into a to the power n un. Well, so 1 to the power n or 1, both are same actually. Let me erase this 1 to the power n, and this a into this will become a n plus 1. Okay, so now let's do this thing when n is tends to infinity, and yeah, a is less than 1. Let's say a is 0.9, let's say. So y infinity will be 1 minus a, then 1 minus, so this thing will become 0, right? So we know that 0.9 to the power infinity plus 1 tends to 0, right? So this thing will be equal to 0 and u infinity. So we know that u is always 1, so let me write here 1. So you see this thing is again 1 minus a, and if I now put that value here, a is equal to 0.9, I will get 10. Okay, so let me do some other values. I have this code here, so actually this code is from Gemini. Today coding is so easy, right? You have available code, just give the difference equation to Gemini and tell him to write this code. Okay, so let me change this thing, a 0.9, let me take it 0.1. so Gemini also suggesting me that change a to value like 0.9 for a slower convergence. Okay, so 0.9 means slower convergence, but if I take 0.1, I think it will rapidly go to the steady state or final value. So let's see what happens. What's happening? Oh, you see, it's too fast. It's too fast, and it takes pretty less time to go to the final steady state position. Okay, so now let's take here some another thing. Let's take here minus, and let's see what happens. I don't know what will happen. Let's see. I'm also exploring this thing. I think here will be oscillating behavior or something. Yes, you see what's happening actually. Well, let me, so you see when I take a is negative, sometimes it's bigger than the steady state. This is actually the steady state or the final position. So sometimes it's bigger and sometimes it's smaller, sometimes bigger, sometimes smaller, and then it approaches to the final position. Okay, so now let's take here 1 and let's see what happens. Okay, oh, it's increasing. Oh, it's increasing. And why? Let's see. Okay, so this is the this is actually the final position, right? And if I take a is equal to 1, so 1 minus 1 is actually infinity. Oh, that's why it's going to infinity, right? Okay, and what about actually this thing? Oh, I understand. So that's why. Okay, so actually I was exploring this thing and I tried to share this thing with you. Actually it's not any tutorial video, or is most of my video you will see that whatever I have learned, I have shared this thing. You can assume this video as like I am sharing something to you, whatever I have learned. Okay, so thank you.